Hello, this is Professor Craig Just from the University of Iowa College of Engineering, and I'll be sharing information related to our EPA funded project titled Connecting Rural and Peri-Urban Farmers to Demonstrate and Disseminate Innovative Nutrient and Sediment Reduction Practices. This particular program is funded by the Gulf of Mexico program with the idea of trying to make improvements in the Gulf of Mexico by practices that we do in watersheds upstream of that location. What we're doing here in Iowa for this particular project has a total cost of a little over $1 million. And of that, about $350,000 will be dedicated to the installation of best management practices at various places in Clear Creek watershed as it leverages practices that are being built with funding from the Iowa watershed approach. And then also we'll be doing some work down here just outside of the Clear Creek watershed at a place called the Johnson County Historic Poor Farm. What we're doing for this project overall is we want to demonstrate and disseminate real results from innovative nutrient and sediment reduction practices implemented in areas kind of where rural and peri-urban folks, where they meet, right? So really where urban folks meet in these peri-urban areas, and the Johnson County Historic Poor Farm is one of those areas. We want to engage rural landowners, small communities, and metropolitan areas in this project. And we want to get some conversations going, farmer to farmer and farmer to consumer, so that then we can better implement some of these best management practices and improve water quality throughout our watersheds here in Iowa. Welcome to the historic Johnson County Poor Farm. Our activities that we plan for the Johnson County Historic Poor Farm are governed by the master plan that was adopted a few years ago. To orient yourself, if you do know Iowa City at all, here's Melrose Avenue as it crosses under Interstate 218. Coming through here, you can see the outline of the property. It's roughly 165 acres, give or take. Goes around this area. Here's the main entry point where you just saw the entry sign that leads in, and then here's a big red barn that was in the background there initially. Some of the practices that you'll see here, there'll be a met station right over here. As we kind of move down through this area in the site plan, you'll see these growing operations, but you'll also see a water control structure that will control the elevation of the shallow groundwater as it's impacted by the tile drainage that's in the area. Then kind of moving down through here, we're working on something called a grass waterway right here in this area. And then we'll also be installing a dam here to create a wetland then that will treat tile drainage effluent that comes into it in this area. Further to the south, eventually you can't see it very well in this image, but there is an alternative tile intake structure being built here that Keith Schilling can tell you more about. And then there's also some work that'll be done kind of roughly down in this area here in the immediate term with our EPA funding to potentially intercept the tile drainage outlet here so that then we can better treat that nitrate. Some changes have been made to this master plan over time, but you can see that they're hoping to have some trail access to bring the community into this area to see the different types of things that are going on. And if you haven't heard the latest about what's being planned for the Johnson County Historic Poor Farm site, please go to their website and ask them for more information. This is a hydrologic station installed in partnership with the Iowa Geological Survey and the Iowa Flood Center. This particular configuration measures rainfall, wind speed and direction, and also measures depth to shallow groundwater. The hydrologic station is shown here on the Iowa Flood Information System, otherwise known as IFIS. By clicking on the station itself, some General parameters are shown here on when the last report date was, what the groundwater temperature is, groundwater table depth, wind, and recent rain. You can get more detailed information here. And then you can also, for example, here's wind, and you can go back in time and see what's been going on. And then you can also see the wind direction as you kind of scroll through these data. Same thing for the well itself. You can get the groundwater or depth to groundwater levels at that particular location over time. This particular site does not have the soil moisture and soil temperature probes installed, but you could get that information at other locations. And then of course we're in a bit of a drought at the moment, and so there hasn't been any rain hardly at all at the site in the past week or so. Hopefully we'll get some soon. One of the objectives of this EPA Farmer to Farmer grant is to better understand and to have more conversations about the impact of tile drainage on our watersheds in Iowa. Here on the left is the drainage network that was installed at the Johnson County Historic Poor Farm a few years ago. For orientation, here's that big red barn on your way in. Here's the meteorological station or the hydrologic station that I showed earlier. And there's tile about every 30 feet apart on these diagonals like this that then are collected then by a kind of a central collection tile that then goes along here, goes all the way down and daylights into a swale that you can see over here in this picture, right on the right hand side. And the same thing happens on the west side of the property. Again, several of these diagonal tiles capturing the water and then again moving it down through this central tile channel all the way down before again combining into that single PVC pipe shown in the picture on the right. One of the things that I want to point out here, since I will show you an image of that in a second, are these water control structures they've got here. So they've got them labeled. There's actually one way up here, but there's one here labeled number 2, one here labeled number 3, 4, 5, and 6. And these water control structures are what can be adjusted to alter the shallow groundwater in ways that can make nitrate processing or nutrient processing in general, but certainly nitrogen processing more powerful and can have a wonderful impact on our water quality that leaves this tile drainage network. The idea behind a water level control structure, as illustrated by the NRCS as part of their drainage water management approach, you can show here that you can take drainage tile that has been put in the ground, you know, as much as 5 foot deep, certainly at least 4 foot deep. You can have that tile intersect this water level control structure that has a series of adjustable riser boards inside, and you can stack those up. Depending on how you stack those, they become, you know, a weir, and ultimately they control then the groundwater table on the other side of this structure. The water then moves over this weir and then can drain out into the drainage area as would normally be the case. And here is a water level control structure at the actual historic Poor Farm site. If we look at the target water levels with such a system, we might look at the growing season kind of after harvest, looking here in October, somewhere in that sort of a date, and seeing that at that particular time there's a minimum water table depth of inches below ground surface of about 6 inches. So we've got that groundwater perched pretty high, and you leave it there during the fallow period. Then when it comes time to plant, you pull all of those risers out of the water level control structure and drain the soil profile all the way down prior to planting so you don't have any issues with equipment getting in and out of the fields. Then after planting, you can raise that water level back up and store it during the growing season, and you can get it perched up while the roots are relatively shallow. As the roots start to increase their depth, you can then slowly pull each of those risers out of that control structure and gradually lower that water table. Bank it all summer long, and then near harvest time, when you want to get the equipment in the fields again, you pull all of the risers up and out of there and drain all the water out. Really, the 1, 2, 3, 4 steps required for this. Again, number one, you remove the remove riser boards to drop water table levels about 10 days before planting. During the growing season, you stack those riser boards to raise the water table high enough to provide capillary water to the crop root zone. Third step is to remove the boards to lower the water table 10 days before harvest. And then last, after the harvest, you want to raise the water table even further near ground surface to hold nutrients in the soil. More specifically though too, while this soil profile is saturated with groundwater, it becomes anaerobic. It loses its oxygen, and the soil microbiology then can also convert nitrate to nitrogen gas when it's in that state, and that's how we end up treating our nitrogen issue here in Iowa. This nitrate sensor uses ultraviolet light to measure the amount of nitrate in the water that's coming out of the drainage tile. The measurements can occur every 15 minutes, could be every hour, could be once a day. It's completely programmable, and it gives us a real-time view of what's going on in the groundwater that's being captured by the tile drainage network. The information from the sensor is wired into this control box. Inside there's a battery and a small computer and a cellular modem that can send the data to the Iowa Flood Center servers that push the data to the Iowa Water Quality Information System shown here. We can see a variety of nitrate sensors around the state, and if we zoom in to the one at the Johnson County Historic Poor Farm, right here, we can switch over here to satellite view, and you can see the Poor Farm site, and then we can click on the sensor and we can view the data as it's been being received over the last few days. We can look at an annual trace here and see that back here when we were first kind of getting going for the season, it was about 3.5 milligrams per liter as N, and then you can see it kind of doing its thing here over time as the water table moves. As the water table changes, the concentration of nitrate can change as well, and so those are one of the things that we want to be able to do, is to look at this concentration over time as a function of rainfall and groundwater saturation and so on and so forth. One of the things that we're interested in doing is looking at these areas like shown here, that in a heavily row cropped area would be a grass waterway, and whether or not we can intercept tile already in the field, put in water control structures like we've shown you here, and then use that soil profile to treat nitrogen. Thank you for listening.